when we looked at scatter plots in the last video, we used our eyes and said, determined whether or not we thought the data that we were looking at um, looked like it was sort of linear. Okay, this last example looked like maybe it had a negative correlation. This example looked like a big mess, and we said we don't think it correlates at all. And this one looked to us like it had a positive linear correlation. So today our job is going to be to quantify that correlation and determine whether or not it truly does have a linear relationship. So some words that I used in the last video, but they'll be defined a little more specifically here, is that x, excuse me, x is the independent variable, and it's the one that can be controlled. Oftentimes that's amount of time or an amount of money or something that can be controlled. And then the dependent variable is the effect, what happens when you spend that much money or spend that much time preparing or studying for something. When we talk about the linear correlation coefficient for a sample, we give that the name lowercase r, and there's a really long name for that. It's the Pearson moment correlation coefficient of something, but a lot of times statisticians and other people refer to it as Pearson's little r. Pearson's r tells us the strength of the relationship, specifically linear relationship. If we're looking for a logarithmic relationship, we've got to go to a different coefficient. But it measures how strong that linear relationship is and the direction, meaning whether it's a positive or a negative relationship. The values that R can attain are values between -1 and +1, inclusive. Okay. If we have a Pearson's R coefficient of +1, that means it is a perfect positive correlation. Okay, meaning all of those points are already in a perfectly straight line. If it's a -1 for R, we have a perfect negative correlation. Okay, now, most of the time, we don't have a perfect correlation. Our sample data is selected randomly, and then the values might be linear-like. But in another section, we'll talk about how close to 1 it has to be, and if I get 0.9, is that close enough, or does it need to be 0.95 or 0.98? But today's section, we're just going to practice finding that R. Now, the formula for finding Pearson's R is a mess. It involves the x's and the y's, it involves the products and the squares, and again, this is on your note card, or that page that I ran off for you in class. But the other nice thing is, just like we used Desmos before to help us plot points, we're going to use Excel or whatever your favorite spreadsheet is to determine that Pearson's R. So our first scatter plot in the last video, let's see if I can make that a little smaller, had to do with income in dollars and the amount that we spent on recreation from those dollars. We said it looks like it has maybe a positive linear relationship, and so I want to find, copy and paste here, I want to find Pearson's R to go along with that. So I have an Excel spreadsheet here that has my values. Okay, notice I'm going to click back and forth for a minute. That we need an XY column. We have our X's and our Y's. Remember these sigmas here? That means we're adding up the values. So I need to add up the X column. I need to add up the Y column. I also need to create an X times Y column. I also need to create an X squared column, and I need to create a Y squared column. Okay. So I, like Excel, I'm going to make those columns here. Okay. To get X times Y, I need to multiply this column times this column. If I highlight down in the corner, see how my fat plus sign becomes just a black plus sign? I can drag it on down and it does what I want it to do all the way down. There might be a squared function in here, but I'm not sure I'm smart enough to find it, so I'll just say that box times that box. That would square what I have. Hopefully none of these numbers get too big. Okay, drag things bigger. Same thing with my y's. Equals y times y. And I need to do that all the way down. Okay. I need to have a sum row right here. So I'm going to add up these x values because I need those. I need the sum of the y's, I need the sum of the xy's, and the x squareds and the y squareds. I need all of those values. Maybe I'll boldface this sum column. Maybe I'll even space it down a little bit. I need that to go away. Why are you not? Sure. I need that guy to go away because I need to be able to see him when I copy and paste here. Okay, there we go. Alright, so now I'm gonna drag all these guys over. Onto my page. And I'm going to do one of these while you were watching me so you could see. And then we're going to plug in the values where they belong. Okay. Maybe a new page would be better for this. Okay, I'm going to pause the video. I'm going to plug in the numbers into my Pearson's R, and then you can turn it. Then I'll turn it back on, and we'll see how close we are. Okay, so pause the video and come back here in a couple minutes once you have attempted to find the R on your own. Okay, so I copied and pasted my table. I didn't have a room on the other page after all. I plugged in for all of the parts in the right place, I hope, and I ended up with a Pearson's R of 0.89. In another video, we will talk about, is that close enough to 1 to be a straight line, or is it not? But what I'd like for you to do in this, also in the next video, we're going to pick up and do the other two examples. So let me find where they are. The one with the blob and this one here. Okay, let's do that one. That does look like it's a straight line first. Okay, that'll be in the next video. And then we're going to do the blob to show that we don't get anything close.